A block sits on a rough table, tied by a thread over a heavy pulley to a hanging weight. Let it go, and everything moves at once. The weight drops, the block slides, the pulley spins up. But friction is quietly stealing energy. How much work does it do in the first T seconds? Watch. Here is the setup. On a rough horizontal table sits a block M1. A thread runs from it, over a pulley of mass M, a uniform disc, and down to a hanging body M2. At time 0, M2 starts to descend, dragging M1 across the table while friction pulls back. Irodov, problem 1.247. Find the work performed by the friction force acting on the block M1 during the first T seconds of the motion. Here is the key idea. The pulley has mass, so it has a moment of inertia, 1/2 mr squared. To spin it up, the two thread tensions must differ, and that unequal pull adds an extra m/2 to the system's effective inertia. Friction, meanwhile, always opposes the block's motion, so it does negative work minus the friction force times the distance slid. First, the acceleration. Newton's law for the whole system, with the disk's inertia folded in, gives A equals m2 minus k m1 times g divided by m1 plus m2 plus m/2. The friction force is constant, F equals k m1 g. Starting from rest, the block slides a distance s equal to 1/2 at squared. Friction points backward the whole way, so its work is negative. The friction work is minus F times s, substitute F and A, and it simplifies to minus k m1 times m2 minus k m1 times g squared t squared divided by m plus 2 times the sum of m1 and m2. So friction does negative work, k m1 times m2 minus k m1, g squared t squared over m plus 2 times the sum of m1 and m2. Remember, a massive pulley adds m/2 to the effective mass, because I equals 1/2 mr squared. Friction here always does negative work, and since distance grows as t squared from rest, the work scales with t squared too. Like and subscribe for Irodov Physics solutions at MathPyHub.